Look, that's so much class. That's really. It's just like casual.
So I'll get started. I'm delighted to introduce our speaker this week. Pat Hastings is Associate Professor of Sociology at Colorado State University. He studies parenting, childhood inequality, and social mobility using quantitative and computational methods. Work considers how social and economic inequality intersect with demographic factors to drive parents' money investments in children, and how children's development responds to those investments. His published work has appeared in American Sociological Review, Social Forces, Journal of Marriage and Family, Demography, and many other high-impact outlets. He has received numerous awards for his research from the American Sociological Association, including the Best Article of the Year award from the ASA Family section 2 years in a row. I didn't even know you could. So
I'm going to see this here.
So today we'll hear about his current research titled Rags or Riches, Predicting Life Outcomes from the Birth Lottery Across 5 High-Income Countries. And we'll hold questions until the end, except for questions of clarification. So please join me and welcome to Pat.
All right, thanks so much. It's really great to be here. Before I get started, I should say first, this is a collaborative project with Zach Carolyn, who's now at the University of Oxford. And also, before I forget, there is a working paper. So, what I'm about to present, I'm happy to share that with you if you just tell me. Okay, so here's the thought experiment. Suppose we have a representative sample of 1,000 children, like for the PSID. Right, we know that unless the economic structure of the US changes in some dramatic way, that in adulthood, about 15% of those children will be in poverty. So we can think of those as the poor. And we know by definition, 10% of them will be in the top 10%. So we can think of those as the rich. So suppose we surveyed all the kids and their parents. We tried to learn as much about them as we could. And then we tried to predict which kids will end up where. Like literally, these 150 kids will be the ones who are poor. These 100 kids will be the ones who are rich. And then we could take this a step further. We could say, all right, let's take the children who are in poverty, right? And we'll try to predict which ones will come out of it, who'll be doing well as adults, have sort of a rags to riches story, right? And which ones will persist in poverty. And in the same way, right, which kids will be rich, which rich kids will still be rich when they're adults, so the persistence of riches, and which ones won't, so the ones who experience downward mobility. So then if we follow up later, question is like how accurate will our predictions be when they grow up? And then we can take this a step further and say how is this different across different countries? Would this predictability differ? And if so, why? So that's basically the quest that we're going to go through today. Okay, Bertrand Russell, the philosopher and public intellectual, is said to have said, when giving some life advice, choose your parents wisely. I don't actually know if he said this, but what I do know is that when I was in graduate school at UC Berkeley, that Mike Howe would often use it when talking about planning social mobility or teaching about it. And of course, it was baked into this sort of understanding. Going Price is Right style now. Okay. All right. So the characteristics of one's the idea is the characteristics of one's family that you're born into have a strong causal effect in determining one's life outcomes. And so this has been sort of described at times as the birth lottery. Of course, it's not literally a lottery with numbers, but instead, social scientists thought about a ton of different factors that are associated, probably in a causal way, with different life outcomes. So we've identified things like income and education and occupation and family structure, and far more. And of course, this is really important research. But one of my arguments is that this focus on these causal effects, explanatory factors, can lead to an overconfidence in our understanding of the outcome. So this picture is over-dramatized. We can imagine, right, you have one child who's from a single parent family, whose mother hasn't completed high school and some food stamps. And on the other side, you have a child from a two-parent family where both parents have finished college and are both working. And so it's easy to think that we sort of know that the child on the left was found poorly, the child on, child on the right, left, or we know there's differences. And of course, like probabilistically, that may be true, But in fact, like whether or not these particular children were turning out poorly or well, right, is something that's harder to predict. And we can look at this with data. So here, this is data, this is from the PSID. We'll go into the data later. But here we have on the x-axis, we have the income decile of one's family during childhood. And on the y-axis, we have the adult income decile. And so we can see, right, for a child born at the bottom income decile, and I'm just there, the third income decile in adulthood. For a child born in the 10th income decile, here at the 8th income decile. This looks like a very linear relationship. It's actually, there's no regression in this, it's just conditional means at each decile. But we could actually do a regression on the underlying data. There's about 11,000 cases here. And if we did that, in OLS, but we'd find that the data on child decile, the 0.54. So we all know that means that one decile increase in child income is associated with a 0.54 increase in the 0.54 decile increase in adult. And of course, it's very significant. So no surprise there. But we can also look at the underlying data. And if we did this, we see a lot more variability, right? So we can see that lots of children who are born at a low income decile, in fact, turn out well. And then a lot of children born in a high income decile turn out quite poorly. And we quantify this in OLS models for an R squared. So we do this, we put an R squared on this particular model. It's about 0.28, which means if you learn in grad stats, 28% of the variation in adult income is explained by child income. So the typical approach of focusing on sort of causal factors, getting sort of explanation, and it's been contrasted with research that's on prediction. So when the focus is on explanation, right, we can carefully choose which variables to include or exclude from a DAG that we may or may not have drawn to try to isolate just the right variation to estimate some sort of causal effect. In contrast, when our emphasis is on prediction, right, we can use far more variables to model far more complex relationships because our goal isn't necessarily to interpret any particular causal factors. So what does this get us? Right, one way to think about this is that if life outcomes can be predicted well based on various childhood features, right, it suggests relatively limited opportunity. So in this case, the birth lottery really matters. Society is fairly rigid. On the other hand, if life outcomes are unpredictable, then this could just suggest a more open society where everyone has more of a chance. Now, it doesn't fundamentally mean it's a meritocracy. It could just mean like a literal lottery, but it just means that like things aren't predetermined at the beginning. If we think about this from a policy implication point of view, right, if we can identify which children will probably end up where, we can think about strategically concentrating our resources on those who are the most vulnerable. If we can't, then this might be an argument for more broad-based or universal interventions. Before we get into this, one more thing I'm thinking about then is that all the examples I've given so far are really based on the US, right? But we could also think that this predictability is something that's going to vary across countries. So there's many reasons I think this might be true, right? Countries vary in sort of huge ways, like their welfare state and labor market institutions. They vary in terms of things like, is that a question?
Yeah.
That's,
Sorry, a clarification. Do you refer to only biological children or also adopted children and parents?
Yeah, so we're going to use we'll use all children, families, so it can be both biological for and adopted. Yeah. So countries vary in terms of things like income inequality, traditional mobility. Obviously, countries vary in terms of your education systems, particularly sort of the tracking of students, certain when and how they track students, the various occupational and educational tracks, the access and costs involved in that, and just the overall emphasis on education and social mobility, and much more. And then something else to think about is that different outcomes could be shaped by different institutions in different ways. So with something like the welfare state, we might think that's going to change how predictable it is. So with poverty, right, something like school tracking systems particularly affect something like the predictability of educational attainment, and something like norms of late closure could be the predictability of the top 10%. So with that background, the questions we're going to answer here are how well can childhood variables, how well can childhood variables predict adult economic outcomes? How does this vary by the outcome? How does this vary by country? And then how does predictability as sort of a measure of a country, right, compare with other country level factors? So to answer these questions, we're going to use the cross-national equivalent file. So what these are is harmonized panel data sets across various countries. All the income measures are based on after taxes and transfers. The sample is going to be adults who were observed during their childhood and then at least once during ages 25 to 35. So we can see, for example, for the US, that gives ID, about 11,500 respondents. In Germany, we have the socioeconomic panel, we have about 700. The other countries here, we're looking at Australia, Korea, and the United Kingdom. The outcomes we're going to predict are in adulthood. So in the full sample for each country, we're going to predict the average number of years of being in poverty. We're going to predict being in the top 10%, predict just overall income decile, like 1 through 10, and the years of education. And then we're going to look at subsamples. So we're going to predict of adults, we're going to predict adults making it to the top 50% when they're born in the top 20%, or the bottom 20%, so that's upward mobility. Adults being in the bottom 50% and starting in the top 20%, so that's downward mobility. Adults being in poverty when starting in the bottom 20%, so that's like persistence of poverty. And then adults being in the top 20% when starting there, so that's like the. And then to make our cross-national comparisons, we're going to use the same predictors across all the models. We have sort of the best apples-to-apples comparison. So the predictors we'll have family income, which are indicators for every income decile, family structure, mothers and fathers' education levels, mothers and fathers' employment status, mothers and fathers' industry, mothers and fathers' education at the birth of the respondent, the number of siblings one has, their birth order, their birth year, their sex, and then indicators for all missing variables. So altogether, this is over predictors. This is fundamentally a prediction project. We're taking a machine learning approach. We're focused on out-of-sample predictability. So of course, we split the data both into some of the data to train the model, and then the out-of-sample data to predict how accurate it is. And the prediction metric that we use is the holdout R squared. So we can interpret this, just think of this as the improvement by the model, which is developed with the training data, in making our predictions in the holdout data relative to if we just use the mean, the outcome, and the training data as our prediction. Unlike in like OLS, the prediction errors can actually be worse than just using the mean of the training data. And if that would happen, the R squared would actually be less than 0. We don't think about what's bad, think about what's good. So what is good prediction? So obviously an R squared of 1 would be a perfect prediction. Like we correctly identified like this person will or won't be in the top 10%, or will or won't be in poverty. Got those all correct, now we have perfect prediction. Is that reasonable? Probably not. So for starters, our first issues, we have measurement reliability and the things we're measuring in the first place. We can think of reliability, which is easier in this row. It represents how well observed scores could actually predict the unobserved true scores. In a paper that Mike Howard and I have in sociological science, we use three-way panel data to basically argue that the reliability of income is at 0.7, the reliability of education is about 0.9. We could really think of this essentially as the same as where you turn this the other way. We could think, so if we knew people's actual true income and tried to predict the income that they gave in surveys, we think that our squared on that would be about 0.7. So we can think of that sort of as a ceiling for like maximum potential that we could possibly get. So that's our ceiling for how good our R squared could be. Yes.
Just about the sample, so you have different countries, right? Is there any consistency across these surveys on how they build the sample? Is it like random sample for some countries?
Yeah. So every country, so each panel survey is independent. It's independently run. And then the goal of CNAP is to create sort of a harmonized panel data set. So the exact nuances of each one are sort of unique and idiosyncratic. And those who publish with any one of them would tell you what many of those things are. CNAP is doing the best they can to try to create so they harmonize the data to make it as similar as it can. But it is true that there are going to be differences. Yeah.
You know, like something that they get from administrative level data, but I can kind of self-select myself to answering something. For example, you don't see me in the future. This can be very correlated with something that I'm not in the labor market, for example. Do you have anything like this or?
So it's not administrative data.
Okay.
They're all, it's all survey like they, through whatever selection process, chose a sample of starting people, and then they're following them over time. Some like the PSAD has been like generations. These others are not. Like they started with a cohort, and they're following. Thanks. Cool. All right. So measurement reliability. We can also ask what's typical predictability. So if you're familiar with sort of this prediction aim, and research, you're probably thinking of the Fragile Families Challenge, sort of the most well-known example of this. So Matt Soganek and many other people tried to predict, in their case, using data, what was in called the Fragile Families data, to predict life outcomes at age 15, based on everything up to age 9. The best predictability they got, hardship, was about R-squared of 0.23. There's actually been recently a follow-up paper where they did interviews with people who they found hard to predict to talk about why it was so hard. And they identified a few sources of error. So one, of course, is just idiosyncratic events that happened in the intervening time period between the last measurement of the predictors and the outcome. Then unmeasured variables that kind of help with the prediction. And then, as already talked about, measurement error. A more recent example of prediction that just came out, statistical methods research by Howard Zhang and Sipa. And it's a little different, but they're using the NLSY to predict life outcomes of their 40s. They do some different things, but when they use the predictors from childhood to predict similar outcomes, they get an R-squared of about 0.20. So this gives us a sense, sort of benchmark our results. All of these examples are just based on US data. You could also think that if we go to other countries, we could get very different results. So our approach, so machine learning approach, we repeated five-fold cross-validation for each country outcome, right? So the idea here is we just split the data by groups. We use 4 groups as training data. There's a holdout data. We repeat this for every group so that all the data gets used as training data and holdout data. The results can still depend on how we randomly split this up. So we then repeat this process over again using different random splits, and the results are fairly stable. And then for each country and outcome, we report the overall mean of the R-squared from all the folds and all the repetitions. The approach we'll use is a super learner, which is an ensemble of multiple learners. So the idea here, just simplified, is we start with 3 base learners. So lasso, random forest, and gradient boosting. And the idea is a super learner assigns weights to do cross-validation. And so the algorithms that predict well get more weight. And so theoretically and in our experience, this produces better predictions than using any single algorithm. But we tried lots of things. And in general, as long as we sort of stayed in this machine learning space and got great results. I'm going to show you results of 3 sets of models. So first, we're going to run a model just using family income and education. So this will sort of set a benchmark for us of how well we can do. Then we're going to add in all the predictors, but just on observations with children between ages 0 and 10. So this is sort of the closest we have to like the birth lottery itself. So this actually excludes South Korea because we don't have observations from children 24 less than 10 there. And then the full model, we use all observations from age 0 to 17 and making our predictions. All right, so here is the beginning of our results. So I'm going to start by showing you the predictability of poverty. So on the x-axis, we have our R-squared, so that's the predictability that we're trying to measure. I have the countries here just sorted by sample size. The US is on top, so just start focusing on that one. So if you take a look at the US, the dark blue triangle represents the benchmark model. So that's just using family income education. We get R-squared at about 0.17. Then we see with the blue circle, that's we add in the predicted stuff for age 10, that gets us to about 0.20. Then we add in everything else, that's the orange square, and that gets us up to an R-squared of about 0.23. But you could ask, like, did this actually like improve this much? The baseline, depends on how you think about it, this is an improvement of about 25% from the benchmark model. Then we got the next country, Germany, right? We see a completely different story. So the family income and education variables explain predict almost none of poverty, right? When we add in everything else, we get to an R-squared of about 0.08, which is still only about a third of the predictability of poverty in the US. Australia and Korea, we see similar levels of predictability with family income and education getting us about halfway there. And we see very low predictability in the UK. So that's one end of the income distribution. Now we think about looking at the other end of the income distribution, which is the top 10%. So here, if we look at the top, we see for the United States, in the full model, predictability of about 0.17. So the predictability of the top 10% is lower than the predictability of poverty. In Germany, we see the opposite. So the predictability in the full sample is about 0.23, which is significantly higher predictability of poverty. Korea has similar predictability to the US, and we see Australia and UK both predictably about 0.08. So how can we interpret this? So sort of in words, right? For the US, poverty, our score is about 0.22. This is far higher than any other country, right? Germany, Australia, UK, all had measures below 0.10. We can think, why is the US so different here? That's sort of conjecturing, but as we think about this, right, compared to other countries, what we're seeing is in the US, what this means knowing a family's background tells you a lot more about whether they'll be poor as an adult, right? So we're getting about the US has your safety net, right? That makes poverty more sticky across generations. With less redistribution means child's disadvantage can map more directly onto adult disadvantage. It's sort of consistent with the story that the US is the essential welfare regime. When we now look at the other end, the top 10%, we see Germany has the highest predictability. It's higher than all the countries. US and Korea follow, and Australia and the UK. In every country besides the US, the predictability of the top 10%, right, is higher than the predictability of poverty. Think about what's going on. So what's up with Germany, right? So Germany, what we're seeing is it has high predictability at the top, even though perhaps the welfare state buffers what's happening at the bottom. In Germany, we have early educational tracking that tracks children into various academic and vocational tracks. We have strong traditions of elite reproduction, heritage advantage, which could mean that family background still matters for making it to the top. Now we'll look at predicting education and income decile. One thing to note right away is that predictability is just higher in general. Part of this is probably just sort of methodological. We have continuous outcomes to span the full distribution. And so the model, the R-squared, gets credit for being close, even if it's not exactly accurate, which isn't the case for the binary predictions, which are just either right or wrong. Also, though, remember that for education, right, the reliability of the measure itself is probably higher than for income, which means that we have sort of a higher ceiling to aspire. So for the US, we see that the R-squared of education is about 0.32, for Germany about 0.28, Australia 0.21, Korea 0.20. The benchmark model with family income education gets us a long way there, but the other factors do seem to improve the model. When we predict one's adult income decile, we see a very similar pattern. For the US, the R-squared is about 0.35, Germany 0.30, and the UK is the lowest at 0.42. So interpreting this, so education income decile more predictable than poverty. So about models of continuous outcomes probably gets credit just for being close, and that explains some of this. Just one sort of thing about here, Korea has by far the lowest predictability of education. Reasons for having very high college completion rates, which should mean that family background, right, has less power to differentiate and predict. And the emphasis on education sort of equalizes attainment across the income distribution. So those are the results with the full sample. Now we'll turn and think about mobility. Okay, so on the left here, we're looking at upward mobility. So this is making it into the top 50% if you're a child from the bottom 20%. On the other side, we're looking at downward mobility. So it's ending up in the top 50% if you're a child from the top 20%. The big observation overall is that with one exception, we have very low predictability. So again, part of this could be methodological. We're now only making predictions of 20% of our original sample, because we see the top about 20%. So that less training data, we have a less good model. But it's also the case, something very substantive here, which is that so we're conditioning on coming from the bottom to the top. So to the extent to which family income was really important for determining life outcomes, if you're only taking children from the bottom of the income distribution, right, then you no longer have income as a meaningful predictor of the outcomes. So these are essentially predictions with just on everything else, conditional on where you started in the income distribution. So overall, we see it's low. The big exception being for Germany, where we see a quite high predictability of downward mobility. If we think about mobility, then we need to think about immobility. Okay, so on the left, we have the persistence of poverty. On the right, the persistence of riches. Again, a very similar story of low predictability, except for Germany, where we see this very high predictability of about 0.30. And then we do see the persistence of riches. So being born at the top and staying at the top is quite a bit higher than immobility. All right, so some interpretation here, right? So from the bottom, right, we see upward mobility has very low predictability. The highest R-squared in the models is about 0.7. So 0.07. So we love our rags to riches story. Actually, very hard to predict we'll actually have that. From the top, we see that persistence of riches is more predictable. Interpreting this, right? So it looks like childhood advantage seems more durable and predictable than disadvantage. In other words, being born rich predicts staying rich. But being born poor tells us very little about this game. Okay, so at this point, you've seen enough to think about questions you may have about the methods. I'm going to talk about two of them, and then you can ask me the rest of what you want to today. And so two things here. So one is we're going to ask, what if we had more predictors? So we use all the predictors that were harmonized across the data, so it can be a comparison. But you might think, okay, it's fairly low predictability, but maybe it would be higher if we just had more things to put in. So we don't have that for all the countries, but of course we have that for some of them. So we take the US, where we have the PSID, and so we add in the following variables, which are things that we think might be associated with making better predictions, right? So we're going to add in the race, wealth, food insecurity, disability status, home ownership, the parents' health, and whether or not the parents have ever been incarcerated, convicted of a crime. So we might think that these things could improve our predictions. And so we can see that result here. So the orange bars are the original predictions for each outcome. And then the blue bars represent the predictions when we use all the old variables along with these added in. And we can see, yes, there is a few sort of percentage point increase in that, but it's not really large. Another question I have is, are we getting higher predictability in some countries, especially the US and others, just because we have larger sample sizes than others? So we use all the data we can in every country, but to test this out, what we do is we take the full sample for the US, which is 11,500, and then we just downsample that to match the sizes of other countries to see how that would affect our results. So we're using the US in all of this, but we're just using different sample sizes to see what would happen. So we go down, we use sample like Germany, which is the smallest, 2,700. The smallest country was 1,800. And then the smallest subsample mobility analysis was 400. And so we can see the top row of each figure is a predictability full model. As we get small, as we go down, we do see there is some drop off in the predictability, but it's actually quite small relative to the difference in the countries themselves. So in other words, like the US with the sample size of Germany still looks more like the US than it does Germany. When we go all the way down to the sample size of 418, we do see a bigger drop off, especially you can see that in that top 3% graph. So maybe there's something going on there. So sample size could be part of the story, but it's not all. All right, so the last thing I want to do is talk about how does this predictability relate to other country level measures. All right, so now that we have the sort of measure of predictability by country, first think about how does that relate to income inequality. So we might think in places with more inequality, a little more spread out contingency distribution, it can be harder to move around, and that can make it more predictable. So we plot the countries here. On the x-axis is the Gini coefficient. On the y-axis is our predictability. I put the correlations there. Note, like, these are only 4 or 5 countries, so like maybe don't draw too much to that. But what we see is that we would expect a positive relationship. We do see that, but we also see that there's quite a bit of noise in these. So it looks like predictability of the same as income inequality. Similarly, we can look at intergenerational mobility. So here we're using the intergenerational earnings elasticities from the Oxford paper with the Great Gatsby curve. And again, we can see sort of a lot of noise here. Interestingly, the highest correlation is between the predictability of education and the IGE, but given this only 10 countries, I can't just keep showing you slides of fly plots, so I'll show you the rest here as a table. So we also look at how our predictability of each outcome is related to the integration of justice and poverty. integration of correlation of education, just the poverty rate, equality of opportunity index, which comes from economists who are working in this direction, and the local social mobility index. And so the overall pattern you can see is that yes, there is some relationship, but it's very noisy, and that no other factor of countries sort of explains well all the different outcomes. So I would argue, right, this is evidence that predictability is sort of a metric alongside things like the IG, GD, and poverty rates, and understanding countries. So summarizing all these results here, our predictability is, I would say, low, but our R-squared estimates are in line with the research, which is based basically exclusively on US samples. What we find is when we add in variables to parental income and education, this often does substantially improve our predictability. We have what we think are the first cross-national comparison of predictability of life outcomes. The general finding is that poverty, income, and education are most predictable in the US, being the top 10%, most predictable in Germany. We have, in general, higher predictability at the top of the income distribution than at the bottom. We find that when we try to predict upward or downward mobility, or the lack thereof, it's overall less predictable, but it does appear that it's higher at the top end. I showed you a little bit of robustness. Adding in more variables in the US did not seem to substantially increase predictability. And the downsampling exercise did suggest that the N was a small factor. And then the last that I showed you, right, was that no country level factor is consistently or strongly correlated with predictability across all the outcomes. So our argument is that predictability should be a distinct dimension of comparative research. So what does this get us, right? So if our varying levels of unpredictability actually reflect differences in the social world, right, and this shows differences in opportunity and social rigidity at different points in the distribution and between countries. As I mentioned earlier, right, there's policy implications here. If we can predict which children will end up poor, end up wealthy, then we could target our resources towards the children we think really are the most vulnerable. We think of policies that do that sort of thing, like early childhood home visits, or means asset transfers, or this whole data analytics thing. If we can't predict well, then it's evidence for, or an argument for more broad-based or universal interventions, right? Things like universal pre-K, universal healthcare, everything with universal in it. Theoretically good and whatnot. On the other hand, if our varying levels of unpredictability actually just reflect limitations of the methods and data so far, then this just means we need better methods and data. So where do we go from here? Next steps, like the general summary, is we just want to do more of this. So lots of kinds of more, right? First, we can think about what if we could do some more countries, like especially more low and middle income countries. We're very limited in the sense of what panel data we have available to us. We could use retrospective data. That opens up a whole other set of issues, but it's a direction to consider. You can really think about adding more variables to our prediction, right? So the PSID results I showed you do give some caution about the limits of survey data, at least in the US, but there's a lot more out there. We can think about things like what happens if we added to the genomic data, what if we had text data. A lot of my other research has been looking at parenting, so it does different types of parenting approaches, explain how children turn out. There's a lot of parents who would like to know the answer to those questions, right? So that's the thing you can imagine studying. We can also wish we had more cases. Of course, there are more surveys we could look at, especially ministry data. Perhaps the Holy Grail is something like registry data, right? So there are sort of similar projects going on using registry data in Denmark, Netherlands, trying to get at some of these questions. We can also think about looking at more outcomes, right? So there's we don't have to just look at economic outcomes. Things about this is studying populations, right? We can think about studying mortality. There's been a couple of recent papers that come out just trying to predict it in this very similar way. We can predict who's going to get married and who won't when they grow up, have children and who won't be when they grow up, or when they don't. And then lastly, we can think about like having more, I said predictions, so more predictors. So who should be making the predictions? So I've thought about this is just machine learning. But one thing I've thought about a lot is if given similar information, what if we had people try to predict the same outcomes? Like how well do people have intuition about how people would turn out? And not just any people. What if we had social scientists like us make predictions about how people would turn out? Like, could we do better or worse? And of course, this being 2026, we could ask, well, how well would AI or LLMs predictions? asking people or social scientists to make predictions to select resources, asking AI to do it is actually relatively easy. So if you have any questions about that, or if we get bored in our Q&A, I do have slides on that, showing those results as well. But I have talked long enough, so I'll stop there. And I look forward to your phone questions.
Do we have any questions?
Yes, I guess how does the extent of income inequality or the prevalence of poverty affect? You mentioned this, right? So is the predictability of, say, poverty lower because some countries just have plainly lower, lower poverty now? Then it gets more difficult to predict this.
Yeah. I mean, so yeah, one expectation coming in is that, like, not expectation, but one hypothesis you might have is that predictability is just sort of capturing like these other sort of country level factors. And if we could adjust to them, so it's a little bit, but what can predict predictability? We put it that way. So that was sort of the point of this exercise here. So we do see, if you ask a question of poverty, so we both use a measure of the sort of the elasticity of poverty. So that's like poverty transfer during migration and just the poverty rate itself. I mean, we would both expect these to be positively associated with higher predictability. And I mean, we see to some extent, like it is higher associated with the predictability of poverty, which we would most expect. So maybe that is there, but then it's very weakly associated with like the predictability of top 10% or of education. So it seems like there could be something there. Like it's not unrelated, but it also seems like it's not, the predictability still seems distinct from that. Okay, okay.
I have a question about your measurements of mobility. And specifically about kind of like what that like fall or like raise in percentile looks like and how different it is between countries, right? So like in an extreme case, you would have like a bimodal distribution, right? Where like falling from the 50% to the 20% would be like really extreme, right? But in other cases, you would have like a narrower fall in terms of life existence, right? So
Yeah.
could you maybe say more about what those kind of like what these like distances and percentile mean like in like people's day-to-day experience?
Yeah, I mean, I can say more about your question. I don't think I can, but yeah. So I think the question I'm hearing is, we say, well, look, like going from the moving from one percentile to another can mean one thing and another. And I mean, I think that makes it sort of a fundamental issue about like how do we compare like economic resources of any kind across countries. So I mean, it's almost like like the. Not only is it like, well, the money is different, but like what you can buy is different. So there's a lot of different sort of underlying things there. So we've just gone with the rank approach. We sort of just turn everything into ranks and then go from there as far as that. So that's it. So I haven't looked at like what the underlying distribution makeup looks like before we did into that. Although I mean, obviously I think all countries still have sort of a long right tail, so I don't know that very future. But we know perceived income inequality is very different between countries. It's like it's a story of like, oh, the reason that like big one is income inequality, that we should have expected that when we did this figure. So yeah, I think I just talked around your question, but that was my shot at it.
I guess I'm interested like in kind of those long tails. So did you try measurements for something that wasn't like at the 20th income decile, but it was like closer to the 10th or like at the more extreme?
We did do more. So one issue is that, so for example, like when we think about like upward mobility, we went from the bottom 20 to the top 50. The reason we did that versus say like the bottom 20 to the top 20 is that that's actually so rare that like we had like very few positive cases. So like then it would be even worse predictability. So like so we did mess around and then choose like sort of a jump. You had like a decent number of people who make the transition, but then of course lots of people don't try to make the connection. So that's why we did that. The same the other way. Like going from the top 20 to the bottom 20 is like like there's very few. So those were the choices that we made in that. Yeah.
Thank you for your talk. I have one narrow question and then a couple of broader ones. I was a little confused by Germany because it seemed to have really high persistence in the top 10%, but then also seemed to have greater downward mobility out of the top. So either I didn't understand that or.
Yeah, so your question is a great one. So remember, so this is predicting downward mobility. But you think about like predicting downward mobility and predicting staying at the top is not like a separate exercise, right? Like if you can predict well who's going to stay somewhere, then that means you're also predicting better who's going to fall out of something. So like,
Oh, so that doesn't mean that there's more downward mobility.
doesn't mean there's more downward mobility. It means we can do better at predicting who's going to experience. So yeah, they're not like identical because here we're going from like top to top, and then this is top to bottom, but also like top to mid. There's a lot of other sort of possible transitions. So that's but these are not unrelated things. So so what I would interpret this, it's not like you've been driving home. What I would interpret is we can predict well, or it's more likely the case that there's more people from the top staying in the top, right? Here, and so that means that's why we can also predict well is down because we predicted well to stay. Yeah, okay, you got it.
So my other questions were more like, I feel like when you show that map with all the flags, I get, you alluded to a good explanation for US, we have such a weak safety net. And then you allude a little bit to Germany that they have this early tracking. But how can we, the UK is also a pretty big outlier. So what do you see going on there? And the other question I have relates to immigration. So immigrants often start off at the bottom, but have high mobility. So do you see the role of cross-national differences and immigrant shares playing any role here? So why UK and what about?
Yes, that's
how
a
do
good
immigrants
question.
share?
So for that, I'm open to all suggestions, presenting the results as they are. So I think one of our first thoughts with the UK is that it was the smallest study, I think. That was part of what motivated the analysis. Doesn't seem like that is the explanation. There could still be something going on. It seems my conceptual understanding of the UK and experience being there doesn't allude to being as like having much predictability in the way that we see it. So I don't have a great explanation. Maybe it's the nature of the sim. Maybe the punches paper, the UK results won't be there. I'm not sure. So anyway, yeah. But I'm open to suggestions on that. What was your other? Yeah.
The differences across countries and immigrant shares.
Yeah, immigrant. So we don't have that. We don't have that in our main data. That's something we could always get. Didn't put that in the PSID data either because immigrants don't really appear in it because of the longitudinal feature of it, which is probably a potential issue with all of these studies. So I completely agree that immigrant status is really odd to have a nice one right back. I don't think in this particular sort of version of the analysis that's probably excluded. I'm about to defer to Paula if I have yeah.
Hi, nice talk. Thank you. I have a modeling question. So the modeling group is an RLS panel, or was it a different type of model?
The models
Yes.
or the so we use random forest. So your question, we use random forest, lasso, and gradient boosting. So it's sort of 3 machine learning approaches. Yep. And then we basically take the results from each one and then weight them to give us what we think are the best estimates according to our cross-validated data.
So my question is, why R square and not an F test or like any of the sensitivity specificity type of performance? Because those might be better for your argument. If you're telling me that you care about the tails, so the top 10% and the bottom percent, I wouldn't be more interested in showing how many false positives in the categorization exist and how well it's actually saying this person is in the top 10% and they are the top 10% versus how many are misclassified as opposed to the R squared.
I see. I get your question. I think we would substantially get the same information on some of the accuracy scores. But what we like about the R formula is it is comparable across the outcomes and more so, right? So if you just think about the accuracy, if you predict something that's not going to happen a lot, right? Then if you just predict that, so if only 10% of people make it, it's about 10%. We just predict that no one makes it there, we're going to be accurate 90% of the time, right? So like that is a 90% accuracy. And so then it's Right, but that's not the point, right? So we want, so the R squared is similar, but the idea is, right, we're gonna sort of adjust that relative to if we took the mean, and so that's the purpose of the measure. But yes, we could use other, like, we could use other accuracy scores to get things, and then we would just need to, like, that would still work well for the comparison of same outcome across countries. It wouldn't work as well for the move I tried to make of comparing sort of how well one outcome is to another outcome. So that's why we go to this. Yes.
Yeah, and the part about that. I wonder if you look at cohort differences, if there are different patterns. So for example, the PSID, if I understood correctly, it's 1982, so it's much older, right, cohort than others. And I would expect more social rigidity, less social mobility. So I wonder if you look at this and if there are differences.
Yeah, so I haven't looked into it, but as you say that, so one idea would be, instead of saying, so what we did is we randomly took people to make a smaller sample. But instead, like, what if we only took like the most recent cohorts and take a look at how that compared? That's a great idea.
That's exactly what I was thinking, because of the point that, they differ a lot there.
Right, yeah, for sure, yeah, and I mean, here the goal was just to use all the people that we could.
Yeah, I get it,
But,
but.
it's a great point. Thank you, yes.
Hey, no, very interesting. I'm trying to wrap my head around the notion of predictability and relation with social mobility. The finding that you can predict poverty in the US pretty well. Does that mean that there is less mobility and how is it different from just intergeneration? But it seems that you're adding a measurement. Can you, give us an intuitive interpretation about the notion of predictability and how it connects with mobility?
Yeah. I mean, so intuitively, they should be related. They don't necessarily have to be, but like, so here, I mean, so what would say, well, what do we mean by mobility? So we have lots of types of mobilities. We think about intergenerational income, education, or housing. This is sort of our attempt to get at it. So here we're using
this is very interesting.
Yes, so that. I guess we could say, like, if income alone is what determined what was driving, I guess, so we could say if income was the only thing that helped us make predictions, then we would essentially expect that the ELS, that using income, right, these would be sort of almost perfectly correlated. Now, the basic elasticity versus that's there's user rank, right? So there are going to be differences. It's not necessarily true, but it should be very close, right? If it's the case that income gets us part of the way, and then if it's income gets us part of the way and everything else is noise, then like this should still be very strongly correlated. If it's income gets us part of the way, but then sort of everything else about a person's family background and characteristics, the birth lottery also helps us predict the outcome, then we're not going to get it right, because there's other factors that don't go into the income part should also like help us with our predictions. So you can think of it, one way to think about it is it's sort of like sort of the using in a sense, like income itself as a predictor is sort of what the elasticity is doing. I mean, it's literally what it's doing, just using the predictor, right? Then what if we put everything else into it, right? That's gonna that can help us make better predictions. But it also helps us make better predictions more in some places than others. And then of course, this is all of that distribution. That's how I'm thinking about it, at least. Yeah.
So it seems to me that the predictability is lower than you were expecting, and then you have some hypotheses about what could be also predicting. In some of the robustness, those didn't really do too much to boost the predictability. Do you have other hypotheses about what could be happening you don't have data on? And have you thought at all, I know that in the PSI ID, I don't know about other studies, but they have like sibling pairs. So you could like take someone who is from the same parental background and income and look at like what could be causing differences there. And then perhaps that would explain some of these predictors on and between households, not only within households.
Yeah, that's a great question. So yeah, as far as like what we should expect, I wouldn't say I expected to have high predictability. I would say that like if anything, actually I would sort of push back against sort of the unpredictability story. So I think that like sort of the whole genre of this literature is coming out, it's sort of like the unpredictability of X or Y or whatever. And so like I've seen when Matt Saganek presents his paper, right, he always points to these R squareds and then he like shows you all the white space here. And he's like, look, like basically look how hard it is to predict out, right? So it's really low. So I mean that's a fair point. It's true, it is low. On the other hand, like my point here about the measurement reliability, right, tell us that like probably like setting 1 is like what we're shooting for, probably isn't actually that reasonable, right? And if we were getting like, 0.5, I would think that was like amazing predictability. And in that sense, if we're getting some outcomes 0.3, like we may not be that far off. And so I would say we have to get like sort of honest or decent predictability. That's how I would think about it. It's a totally subjective question, sort of what's higher though. So sure, the question like yours was sort of like, well, you added a bunch of other things, but maybe we could still add more things. And finally we would break through. And that seems very possible. That's just an empirical question. So I think one direction I would take it is using, like the goal here in our project, we really want to make a comparative study and look at different countries. And so then we sort of acknowledge we were limiting sort of the data we had to do that in order to make some good comparisons. We're not making a claim, right? Because of the variability, we're not making the best possible predictions that we could have for any bigger country, right? So if my goal was really, could I make the best possible predictions for like people out there, then I would, zero in on the US or, well, I don't care, whatever it is, so so we're not making a claim these are the best possible predictions that we could get. So sort of these are the most comparable predictions we could get. That's how I would think about it. Thanks.
I guess I'm wondering if a question about this, a slippery slope in interpreting this, right? So you said in that on one hand, this is about predictability, not understanding the life course patterns of how stuff unfolds. So it's all about predicting, right? Then at times you argue, the usefulness of this is how we target policies.
Yeah.
But then that is exactly a life course determinant, right? So I guess I'm wondering, right? On one hand, you say you're not studying life course determinants, it's all about statistical predictability and kind of ignorance of what we study as social scientists, how life unfolds and what we determine outcomes. But then in some of the interpretations, you say, look, by being able to predict it, this tells us where we should target policies. But the predictability, as such as you said, it's not clear we should make any of these predictions because it's just predicting and the processes could be very different from the variables you pick up as predicting. So I guess the question is, what do we at the end of the day, other than predictability, what do we learn from?
Yeah, so I mean, I think it can be a both and sort of thing. So on the one hand, we could think that if we had really good predictions, good being relative, right, then we could identify sort of the people we want to make interventions with. But as far as like that doesn't tell us what the intervention is going to be, right? And so, right.
Storks predict fertility trends, like something like a silly prediction. There's no policy for it. Number of storks, right, has been declining, fertility has been declining. So the predictability of storks on fertility trends in the 20th century is very high. There's no policy to believe. Right.
Yeah. I mean, the R squared on storks.
So fertility is high.
It's probably not that high though. Just to play. I mean, if we could actually say, oh, like we could look at storks, going with it. If we could look at like stork flight patterns and predict there's going to be like more fertility increasing here than here, we could adjust policy to deal with more or less fertility. So that's not like right. So the thing that could give us insight into sort of what's going to happen, right? This is we're predicting the future, right? If we could predict the future with whatever tool, just because that tool doesn't then tell us how to deal with the future, doesn't mean it's not useful to know what's coming, so that we could intervene through other, right? What we think of as the interventions could be something that's very different. So that's how I'm doing it. If in fact we could use storks to predict, if we thought that what we observed about storks actually was helping us predict what fertility will look like in the future, then like
we need more storks.
But then we would do it, and then what we would use is different. So I don't think the goal of prediction takes away from needing sort of the understanding of like what should we do, right? But I don't think, but knowing where we could target them, that's a viable thing. And I think that that's the useful, so that's how I think about it.
So I think it's related to this point. Imagine like you cannot predict income, but like, for example, we don't have in the model what Chatty has been talking about, that because you're rich, you have access to other networks, right? And then when we think about policy implications, if you think about not targeting, for example, the poor, because we can just not predict, but we are denying a lot of ladders for social mobility. So for example, income predicts social access to education, for example, right? But not only predicts, but it's also very causal. We have a lot of things showing that these ladders matter. And then when you think about a universal treatment of these different groups, because we cannot predict, for example, something well, I think we're missing exactly what you're talking about in terms of there are things we cannot predict because it's the nature of the prediction. We cannot predict this because it's random, it's a lottery. I don't have good data maybe, but there are other things that are tiny and maybe they could be more effective to study, for example, and not to study, but more effective to target, for example, education or social mobility through education, social mobility through networks that are targeted policies, even though we cannot predict, for example, income impacting social mobility. And I think that this is my only feedback about the policy application. It looks for me very strong to say that a universal, because we don't know too much of these mechanisms, then not targeting, it's a very strong assumption for me. Because we do know that other small things that will make you go into the ladder of social mobility do matters, and these are targeted policies, right? And in income, yeah, it's a good exercise of prediction, but had so many other things. For example, in countries as Brazil, income is something, but predicts a lot of other things. For example, race, you have gender, you have social network, you have your neighborhood, right? And I think that's just my feedback in terms of the policy implication, is that I think measuring how we are going to do universal or a targeted policy because of a prediction of something, I think for me it's a very strong assumption. As we are missing a lot.
I understand your take, yeah. I mean, I think these are fair points, but at the same, a lot of what we understand about sort of how well interventions work is again because we are focused on estimating some sort of causal effect, right? And a lot of those studies, right? If you get, yes, like we show evidence of effects, but the variability in those outcomes is enormous, right? So they may have an average effect, but actually, like whether or not they will help this person versus that person, we often have extremely low. We just sort of taken that as sort of accepted. I mean, if we lived in an infinite resource world, then we wouldn't worry about these things. It's to all the things, but we don't, right? And I would also say like the idea of like targeted intervention is something we're doing anyway, right? It's like we do this, we do means tested things, we choose people, right? And so since we could ask like if we're going to be targeting interventions anyway, right? We should target them potentially in the best way we can. I'm not, yeah, I'm giving you predictions now. I'm just drawing out what the implications could be. So yeah.
One more last question. There are external shocks such as 2007, 2008 recession. And I thought that when people entered the labor market, the timing could make a difference. I wonder if you thought about thinking a little bit about these six shocks that would happen worldwide, especially like with the whole.
Yeah. I mean, the closest we come to that is you know we have sort of a predictive framework. We have like birth year mixed effects. So you know, that means whatever year that you sort of became an adult, like that's going to be part of our prediction. So if you became an adult in the recession, that's building our prediction. You became an adult during the Gulf War, that's in our. So any shocks that were experienced by everyone in a country, not by every, but these clear global shocks, they should be built into our predictions in that way. Yeah. Thanks.
That takes us right up to time. So we'll wrap up. Thank you very much for a great presentation. Quiet.